Hello everyone and welcome to class of NSA Radio Protocol Architecture. NSA as non-standalone radio protocol architecture. So here we have two planes, control plane and user plane. So let's start with NSA. So in ENDC, which is non-standalone mode, the UE has a single RRC state. So based on mobile network radio resource control and a single C-plane connection towards the core network. Each radio node has its own RRC connection entity. That means EUTRA version if the node is in E node B or new radio version if the node is GNB. It can generate RRC PDUs which could be sent to the UE. Now RRC PDUs generated by it can be transferred by the mobile network to the UE. The mobile network always sends the initial RRC configuration via the SRB1, but subsequent configurations may be transported via mobile network. When transporting RRC PDU from the network, the mobile network does not notify the UE configuration which is provided by its own SN. This is architecture for NSA or ENDC. ENDC basically stands for EUTRA New Radio Dual Connectivity. So we call it as like NSA non-standalone EUTRA New Radio Dual Connectivity. We can see this is the architecture. Here we have ENB, RRC, UE, RRC, and this is New Radio RRC source GNB. This is the UU interface, and here we have X2C interface between these two. As we are discussing about EUTRA New Radio Dual Connectivity, this is EUTRA, then we have New Radio Dual Connectivity supported by X2C interface. Now move to the user plane. In EUTRA New Radio Dual Connectivity, from a UE perspective, three bearers exist. We have MGC bearer, SGC bearer and split bearer. For this ENDC, the network can configure either EUTRA PDCP or New Radio PDCP for MGC bearers. And while NR PDCP is always used for SCG and split bearers. So here we can see the architecture of all the bearers. We can see here. MGC bearer to EUTRA NR PDCP and split and SGP for new radio itself only. This is the UE MAC. SGC, like we can see, this is a secondary cell bearers, split bearer both, NR, RLC and EUTRA. This is for both. This is only dedicated to RLC. This is for RLC and EUTRA and this is for connectivity of both. Now let's move to the next, which is standalone radio protocol architecture. So in this also we have control plane and user plane. So this is control plane protocol stack. Here we have PDCP, RLC, MAC sublayers. RLC, PDCP, MAC sublayers, RRC, non-access datum, control plane. This is for non-access datum is for authentication, mobility management and security control. RLC, MAC, RRC and NAS control plane. and this is the user plane here, the user plane protocol stack. Here in this we have STAP, PDCP and RLC and MAC. These are all the protocols for user plane. So this is a stack of user plane protocol. Thank you.